from ChemPraxis, and today we'll be discussing Chemistry Paper 4, Variant 2, May-June 2024. For the first question, a list of gases is shown. Answer the following questions about these gases. Each gas may be used once, more than once, or not at all. State what gas is the main constituent of natural gas. The main constituent of natural gas that we can find from the list of gases given is methane. What gas is responsible for both photochemical smog and acid rain? Nitrogen dioxide is responsible for both of these. What gas is unsaturated? The only unsaturated gas is propane. What gas has monoatomic particles? Helium is the gas that has monatomic particles. And lastly, what gas reduces iron 3 oxide in a blast furnace? Carbon monoxide would be the gas that reduces iron 3 oxide in a blast furnace. For part B, nitrogen dioxide and carbon monoxide are removed from a car exhaust by a catalytic converter. For part B, nitrogen dioxide and carbon monoxide are removed from a car exhaust by a catalytic converter. Write the simple equation for this reaction. The simple equation for this reaction will be 2NO2 plus 4CO equals to N2 plus 4CO2. Remember to balance your equation. For the second question, a list of 5 metals is shown. All metals form positive ions. So, describe how atoms form positive ions. Atoms form positive ions when outer shell loses electrons. State which of the 5 metals in the list has the greatest tendency to form positive ions. From the 5 metals in the list, we can determine that potassium has the greatest tendency to form positive ions. Suggest one of the 5 metals in the list which is not likely to show catalytic properties. There are 2 answers to this question: magnesium and potassium. However, according to the question, suggest only one of the 5 metals, hence you can pick either magnesium or potassium. In my case, I've picked magnesium. State which of the 5 metals in the list is a major component of stainless steel. A major component of stainless steel is iron. Part B. A student adds a sample of a metal to an aqueous metal salt in a beaker to see if a displacement reaction takes place. Complete table 2.1 to show the color of the solution in the beaker at the start and at the end of the experiment. For magnesium, the aqueous solution is iron 2 sulfate, and hence, the color at the start will be green. And once the reaction is complete, the color should be colorless. For silver, the aqueous solution will use is copper 2 sulfate. The color at the start should be blue, and at the end, it should also stay blue. Part C. Most group 2 metals form a gas when placed into cold water. An alkaline solution is also formed. Name the gas formed when strontium is added to cold water. The gas formed when strontium is added to cold water would be hydrogen. Name the alkaline solution formed when strontium is added to cold water. The alkaline solution would be known as strontium hydroxide. One group 2 metal reacts very slowly when placed in cold water. When heated, the metal reacts with steam to form a white solid. Identify this metal and name the white solid formed. The group 2 metal that reacts very slowly when placed in cold water is magnesium, and the white solid formed would be magnesium oxide. Next, under certain conditions, iron will react with steam to form an oxide of iron with the formula Fe3O4. Fe3O4 reacts with dilute hydrochloric acid to form a mixture of iron 2 and iron 2 salts. Fe3O4 reacts with dilute hydrochloric acid to form a mixture of iron 2 and iron 3 salts and water. Deduce the symbol equation for the reaction between Fe3O4 and dilute hydrochloric acid. Your equation should look like this, and ensure that you balance the equation. For question 3, the symbol equation for the industrial production of ammonia is shown. Name this industrial process. This industrial process is known as Haber process. State the meaning of this symbol. The meaning of the symbol is the enthalpy change. And next, state the typical conditions and name the catalyst used in the industrial production of ammonia. The temperature of the industrial production of ammonia should be at 450 degrees Celsius, 200 atmospheric, and the catalyst used should be iron. State 2 methods of increasing the rate of this reaction. In order to increase the rate of this reaction, we'll have to increase temperature and/or increase pressure. For part E, the symbol equation for the reaction can be represented as shown in figure 3.1. Table 3.1 shows some bond energies. Use the bond energies in table 3.1 and the enthalpy change to calculate the bond energy of NH bonds in kilojoule per mole. Calculate the energy needed to break bonds in the reactants. To do this, we'll use the bond energy given in table 3.1. So this will be 945 plus 3 times 435, as there are 3 of each of the H bonds. Your answer will equal to 2250. Next, calculate the energy released when bonds form in the products. To do this, we'll use the answer we got from the first part, add it with the enthalpy change given. Your answer should be 2340. And lastly, to calculate the energy of an NH bond, we'll use 2340 divided by 6. Your answer will be 390 kilojoules per mole. An incomplete symbol equation for the preparation of ammonia in the lab is shown. Your symbol equation should look like this. Name NH4Cl. NH4Cl is ammonium chloride. Next, calculate the volume of ammonia measured at room temperature and pressure, which forms when 1.12 grams of CaO is heated with excess NH4Cl. To calculate for the mole of CaO, we'll be using the formula of mass over mR. The mR of CaO is given, and as well as the mass. So to get the mole of CaO, we'll use 1.12 divided by 56. You should get 0.02. To calculate for the mole of NH3, we'll use 0.02 times 2. This should equal to 0.04, and for the volume of NH3, we'll use 0.04 times 24,000, which equals to 960 cm3. For question 4, a carboxylic acid reacts with an alcohol to produce an ester and water. Under certain conditions, this reaction can be reversed, so an ester reacts with water to produce a carboxylic acid X and an alcohol Y. The reaction reaches an equilibrium. The forward reaction is endothermic. So, deduce the empirical formula of the ester. The empirical formula of the ester should be C2H40. Name the ester. The ester formed would be methyl propanoate. Name carboxylic acid X and draw its displayed formula. Carboxylic acid X would be a propanoic acid, and your displayed formula should look like this. Next, name alcohol Y and give its structural formula. Alcohol Y is methanol, and your structural formula should look like this. For part E, complete table 4.1 to show the effect, if any, for each change of condition. When temperature is decreased, the effect on the concentration of carboxylic acid X at equilibrium also decreases. When concentration is decreased, the concentration of carboxylic acid X at equilibrium decreases as well. When more alcohol Y is added, this also decreases. When a catalyst is added, there is no effect on the concentration of carboxylic acid X at equilibrium. At the beginning of the reaction between the ester and water, no carboxylic acid is present in the reaction mixture. Suggest how the pH of the reaction mixture changes from the start of the reaction until equilibrium is reached. Assume alcohols and esters are neutral. The pH at the start of the reaction should be 7, and the pH at equilibrium should be around 4. Or you can get a pH within 3 or more, but less than 7. Identify the ion that causes the change in pH. The ion that causes the change in pH would be the hydrogen ion. Name an indicator which can be used to follow the change in pH. A universal indicator can be used to follow the change in pH. For question 5, a sample of sulfur contains 2 isotopes. Complete table 5.1 to show the number of protons and neutrons in one atom of each isotope of sulfur. There are 16 protons respectively in both isotopes of sulfur, and for the neutrons, sulfur 32 has 16 and sulfur 34 has 18. State why these isotopes have identical chemical properties. Isotopes have identical chemical properties because they have the same electronic configuration. State the mass of 6.02 times 10 to the power of 23 atoms of 34 sulfur. The mass of 34 sulfur will be 34 grams. State the name of the amount of the substance which contains 6.02 times 10 to the power of 23 atoms. The name of the amount of substance would be 1 mole. Table 5.2 shows the relative abundance of these isotopes of sulfur in the sample. Calculate the relative atomic mass of sulfur in the sample to 1 decimal place. To do this, we'll have to use the isotope numbers and the relative abundance. So, 32 times 95 plus 34 times 5 would equal to 3,210. 3,210 divided by 100 would give us 32.1. Hence, the relative atomic mass should be 32.1. For part B, complete the dot and cross diagram in figure 5.1 of the ions in magnesium sulfide. Your dot and cross diagram should look something like this, and the charges of the ions should be 2 plus and 2 minus respectively. State why MgS has a high melting point. Magnesium sulfide has a high melting point because ionic bonds are strong. State why molten magnesium sulfide conducts electricity. It conducts electricity because ions can move around and are mobile within the magnesium sulfide. An acid containing sulfur reacts with sodium hydroxide to form a salt and water. The salt has the formula Na2SO3. Deduce the formula of this acid. The acid's formula would be H2SO3. Next, deduce the formula of the anion in Na2SO3. The formula of the anion in Na2SO3 would be SO2-3. Na2SO3 is oxidized by acidified aqueous potassium manganate. State what the Roman numeral refers to in the name potassium manganate. This Roman numeral refers to the oxidation number of manganese. State the color change when this reaction happens. The color should change from purple to colorless. And for the last question, glucose is involved in 2 processes. Glucose is made in plants from carbon dioxide and water. What is this process? The process in which glucose is made in plants is known as photosynthesis. Write the symbol equation for photosynthesis. The symbol equation for photosynthesis should look like this, and ensure that you've balanced the equation. State 2 essential conditions needed for this process to happen. We'll need energy from light and the presence of chlorophyll. Without chlorophyll, photosynthesis cannot occur. Glucose is converted to ethanol. Name this process. This process is known as fermentation. Name the other product formed when glucose is converted to ethanol. The other product formed would be carbon dioxide. Ethanol is made by reacting ethene with steam in an industrial process. State the conditions and type of catalyst used in this industrial production of ethanol. The temperature of the production of ethanol should be at 300 degrees Celsius with 60 atmospheric, and the type of catalyst used should be an acid. Explain why this reaction is an addition reaction. This is an addition reaction because only one product is formed. Complete the dot and cross diagram in figure 6.1 of a molecule of ethanol. Your dot and cross diagram should look something like this.